Hey everyone, and welcome back to Fill Engineering. Now a little while ago I turned 5 square meters of empty space into this awesome machine shop. And don't get me wrong, I absolutely love the way the shop turned out, but it has one major drawback. Trying to fit tripods in here for a proper camera and some lighting is basically impossible. And the only way to solve this problem is building an overhead camera gantry system. And I bet you have seen something like this before. Brandon from Inheritance Machining made one of those a while ago, so in order to not copy his design, I think I need to step it up a bit. So this is what I want to build. It is basically a bigger version of this microphone arm, just on a movable gantry that will let me position the camera anywhere I want. But getting this right under the ceiling is pretty difficult in this case, because the ceiling itself is hollow and the rails I bought are quite heavy. Both walls aren't flat or parallel with each other, and there are these pipes running in mid-air for whatever reason. To solve all of these problems, I'm gonna build a pair of wooden trusses that will span across the entire shop. This might seem a bit overkill, and it probably is, but it will carry expensive camera gear, so cheaping out on this is definitely not worth it. So let's start by cutting everything to size. This is straightforward, as I can just position my stop to the correct length and then cut as many parts as I want. And as you can see, they are exactly the same size. This is everything cut to length, but the 45-degree parts still need some more cutting. Again, I'm using a stop, which makes this just a matter of minutes to go through all of them. And one more cut gives me a 90-degree corner. Now I can assemble everything. Don't expect any fancy joinery here, I'm just using glue and long wood screws. At first I thought this would take ages to assemble, but in the end it just took a few hours. Every truss is segmented into 3 parts, but now I need to join 2 of them together. The last piece will be joined when it is right under the ceiling. Not the easiest thing to get right with only 2 hands, but I managed to do it. The main joint gets reinforced from both sides with these plates I made. Of course I checked my construction with a highly scientific load test. This piece spans across 4 meters and I'm sitting right on the weakest point. So I think it is strong enough. I have a lot of paint left over from when I built the anti-fatigue mats, so I gave everything a good coat which protects the wood from moisture. And it looks good. For the rails I decided to mount them with a gap so I can adjust their position later, just in case the 2 trusses are not perfectly parallel with each other. Now comes the fun part, lifting this thing into position. It barely fits around the corner, but I managed to get it on top without breaking something. At the end I prepared an anchor point where I can slide it in from the top so it can tip over. And now it gets really difficult. I need to lift both parts into position with glue applied, and then I have to clamp them together with only one hand. And it was a bit tricky, but luckily it went just like I hoped. And of course, this joint gets reinforced too. And now I have to do all of this again for the other truss. I installed a few brackets just to play it safe, and I have to say, this is incredibly strong. Definitely not going anywhere. But enough woodworking, let's fabricate the moving part of the gantry. Alright, that went pretty smoothly. So here's what I came up with for the rollers. Each of the blocks get 4 bearings with plastic sleeves which will guide the block inside the rail. I turned these aluminum shafts on the lathe which will get pressed into the bearings. The horizontal bearing will be held in place by the mounting screw. Because the roller blocks are 3D printed, I welded on those T-shaped pieces so this doesn't crash down on me if the printed parts fail. The mounting screws run all the way through them, so they should be very strong, but better safe than sorry. The hooks are also 3D printed, but I need laser cut parts for my next project, so I will get a pair of these hooks made from steel, but for now they will work just fine. So it is time to lift this thing into the rails. I try to maximize the travel, so getting this in is a bit tricky. And before playing around with this, I'm closing off the ends to prevent it from falling out. And honestly, this is rolling much smoother than I thought it would. Now I can finally machine something and build a central shaft that will hold the camera arm. Here's the finished shaft. It has slots so the hooks can hold it in place, and I'm adding 3D printed stripes around the tube which will take up any slop and protect the paint from getting scratched. So let's do a quick test fit. Works pretty good, but it could have just a tiny bit more clearance. And I will optimize the fit off camera. Now, here's the deal. I actually made 3 sets of movable gantries. One will hold the camera arm, which will be made from solid aluminum, and 2 additional arms made from 90% 3D printed parts for holding lights or the GoPro or whatever. And this only took 250 hours on my old Prusa Mark III. Let's make the swing arms first. I'm going for a double arm design. This allows me to place a tensioning mechanism between the arms to adjust it to different weights. The arms are straightforward, just a few holes and some countersinks. The ends get reinforced to accept these plastic sleeves. And here comes the human rotary table. But don't try this at home. And that's 8 of them all finished. The tensioning mechanism consists of 3 parts I need to machine. A dynamic part that connects to the spring, a piece of all thread will run inside a static block and the position gets adjusted with this knob. I need every part 4 times, so let's get to machining. Alright, this is getting somewhere. Of course I saved the best for last. The 3 main parts of this arm will be made from this block that is already milled to size, but it is too small to make the camera mount in one piece, so I will have to split it into two pieces, but that is not a problem. Took quite some time in the saw, but it really is a big block. Since all parts share almost the exact same features, I won't show you the same operation over and over again, but I will show you all of the parts after each step, so you know where we're at. And after 2 days of non-stop milling, all the parts are finished. I made a few washers and other stuff off camera, but I think you can imagine how this went. What you cannot imagine is the monstrous amount of chips on the milling table. This will be fun to clean after this project is over. So let's finally assemble it and see if it works. Looks good so far, time to attach it to the gantry. This washer will make sure that it can't fall down even if the printed part fails. And it acts as an end stop for the locking knob. It took a while to find a set of springs that is just right, so I didn't film much of the trial and error. But in order to adjust it to the weight, it needs a camera mount. I made these spherical parts just like on a video tripod, so I can level the camera if I need to. From there, it is just a matter of tensioning the springs, and this thing is done. So let me show you why a camera gantry is such a big deal in my case. First of all, it can be positioned within seconds. But it also opens up new camera angles. It can float directly above a moving object like the milling table, get into tight spaces where a standard tripod would be very difficult to set up, and making overhead shots is just so much easier and nicer because I can finally see what I'm actually doing. So, does any of this stuff make me a better filmmaker? No, of course not. There is so much I need to learn, and this system opens up so many possibilities, and I cannot wait to use it in my next project. I hope you enjoyed following along, and thanks for watching.